Are squats and deadlifts overrated? Today we're going to break that down and see why some exercises are overrated while some exercises are underrated. So, exercises, in my opinion, should be used as tools. So you can put it in a perspective like a squat should be viewed as a drill. A drill has many drill bits, some for steel, some for wood, some for concrete. You get it. So if a full squat, is just the drill, then you put the steel drill bit, it's a half squat. So it serves a different purpose. You put the drill bit for wood, it's a quarter squat. It serves a different purpose as well. So exercises are used to achieve adaptations. Adaptations are our body's response to the training stimulus. If we put enough specific stimuli on our bodies will provide the response for the thing we put it through. So if you jump enough, you'll jump higher. If you sprint enough, you'll sprint faster. That's the basis of adaptation principles. So let's talk about different adaptations now and how do we achieve them, and are conventional strength training exercises enough to achieve these adaptations. So let's talk about hypertrophy. Hypertrophy is pretty simple. Everybody knows what it is. It's the increase in muscle size. It can, if you want to go cellular level, you can say it's the increase in a muscle fiber size. So how do we achieve it? There are different types of exercises and exercise modalities and principles to achieve this. The biggest thing those exercises have in common is high muscle tension or high mechanical tension. The one exercise that is really pushed for hypertrophy, especially in the legs or quads, is squats. 4 sets of 8, 3 sets of 8, 4 sets of 10 or 12 or whatever you want. But there lies a problem in those rep ranges and set ranges, that we lose strength. But if you shift your focus towards the adaptation, not the training system of squats, you can do super maximal eccentrics, or you can even do overcoming isometrics for 5 to 10 seconds. You will get the same results with hypertrophy, but your strength will either go up or stay the same. So does it really make sense to use squats for quad hypertrophy? In this example, I use squats, but you can use it on RDLs, on calf raises, on every part of the body you like, because the principle is the same. You have super maximal eccentrics that give you more forces but achieve more hypertrophy. And possibly it could achieve different adaptations, but we're not talking about that today. I'm talking about pronation angles and muscle architecture, but that is a topic for a different day. So now let's talk about strength. Strength is how much force you can express. Power is how much force you can express through a certain time, but strength is just maximal strength. How much force you can express through one exercise, let's say. It's the closest thing you have to a 1 rep max. So strength is achieved through really heavy lifts, usually conventionally, and with those heavy lifts, like 6 sets of 3 with RP 9 to 10, you achieve strength and you achieve hypertrophy also. But you could also achieve strength through all ranges of motion if you focus on overcoming isometrics and you push for 1 to 5 seconds. I like to use 3 seconds. on a lengthened position. So if you're doing it for let's say squats, you push from a deep squat position, from let's say S to rest position, and you achieve adaptations of strength through the whole range of motion. The principles is also the same through every muscle group and every exercise known to man. Good thing about overcoming isometrics is that it also increases neural drive and has some neural adaptations, but we'll talk about that later in the video. So now that we've covered the two most simple adaptations, strength and hypertrophy, we can cover a little bit more complicated things. I'm talking about explosiveness and speed and tendon and muscle stiffness. So explosiveness is a broad term. You can see explosiveness as power or as a mere showing of force in the smallest amount of time you can think. So how do we achieve explosiveness? Explosiveness, I will see it through the lens of jumping because I love jumping and I know most about jumping. You achieve jump height firstly by using general preparation, then you do strength, then you do like a power cycle, and you peak with the most specific things to jumping, with plyos, with decreased range of motion lifts and things like that. So if we look at explosiveness like as much force we can produce through the smallest time window, we can also see exercises like overcoming isometrics again as explosive. So you can do leg extensions in a deep or small range of motion, whatever you want to use, and you just push for 1 second as hard as you can, and then you let go. That is also explosive, and that's how you increase neural drive and explosiveness, and you shift those muscle fibers in your quads. One adaptation that is also caused by this type of training and plyometrics is muscle stiffness. So you can achieve muscle stiffness through those isometrics or through plyometrics. In what muscle you want to achieve those adaptations, you do plyos for that. So if you want to achieve muscle stiffness in gastrocs and soleus, you use pogo jumps or something that really involves the flexors and extensors of the ankle or the foot. If you want to achieve stiffness in your quads and hamstrings, you do something that engages those extensors of the knees and flexors of the knees. But those same exercises decrease tendon stiffness. So if you want muscle stiffness, you decrease tendon stiffness, and you have to use something else to get that tendon stiffness back. The thing you use for tendon stiffness are isometrics. You can use yielding isometrics, or you can again use overcoming isometrics, but in more of a hypertrophy range, like 5 to 10 seconds. Studies show that those ranges increase tendon stiffness the most, but if you increase tendon stiffness more and more, it will negate your muscle stiffness increasing. So you have to be very careful with your tendon stiffness and even your muscle stiffness, because then your whole musculotendinous system will be too stiff to produce force. It will be like a hard rubber band that you can't pull on, and if you pull too hard, it will tear. So if you have too stiff muscles and too stiff tendons, something is bound to happen and something is bound to tear. So the last thing I want to touch upon are neural adaptations. Neural adaptations that mostly intrigue me because of my background in dunking and jumping is rate coding. So rate coding is the frequency at which brain sends signals to a certain muscle or a motoric unit. So how do we increase this? We increase this through maximal engagement of that certain muscle. How do you achieve maximal engagement? Most people use powerlifting techniques. So you do 1 or 3 rep max lifts and you think those will increase neural adaptations. They will, but to a certain degree. If you do super maximal eccentric training, they will achieve even more adaptations with better structural adaptations for it. And if you do overcoming isometrics, you will get both hypertrophy, strength, and those same neural adaptations that you're chasing for you to increase explosiveness and rate coding. So we should stop looking at exercises through the lens of conventional strength training and through the lens of classical coaches. We can learn a lot from them, really. I'm not saying that Verkhoshansky and all of those guys, the NFF, are wrong. But we have modern science and modern coaches that can use that same science to add onto training philosophies of those old coaches. So once again, use your critical thinking and create your own training systems that work. Thank you for watching.